Welcome back, everyone. Welcome to the last day of BalCCon. Our first talk of today is about bringing mixed reality to our web pages. Please welcome Marko.
Thank you all for coming. So today we're going to talk about some new interesting things that are coming to the web. Generally we're going to talk about mixed reality, but also what does mixed reality means and how did we get to this stage of bringing the mixed reality to the web. Some short things about me. So I'm a front-end engineer at a Berlin-based company. I'm also a PhD student and a lecturer at DAFED. Also do some book reviews for Manning, mostly JS topics. I can advise you to do the same. It's voluntary and you can always learn new things. And generally JS enthusiast, so you can also ping me on Twitter. So what we're going to talk about today. So here are some short topics. So like history, how do we end up here? We're going to make a short intro to WebGL and 3JS. We're going to explain what are those things. We're going to show how we work in the Visual Studio Code with the plugins that we need for this. We're going to demonstrate how to import 3D models to our VR, AR scenes. And we're also going to create a couple of these scenes together. And for the end, we're going to talk a little bit about WebXR and the future of web in this domain. Generally, for skills and tools that you need for following this, basically elementary JavaScript knowledge with some HTML, CSS. Everything we're going to show today is on my GitHub page. There's a link later when we come to the examples. And you need Visual Studio Code with these plugins, but also you can work in basically any other IDE, like Sublime, Atom, whatever editor you want to use. The only benefit of the Visual Studio Code is because you have these plugins for 3D models. Also, Chrome browser, you can work in another browser. I'm just demonstrating it here with this browser and their developer tools. You're going to need some sort of an HTTP server, so because we're going to load files, so you need something, basically you can use HTTP server, you can use Python server or whatever. So that's it. So let's go to the story of how did we end up here. So basically WebGL or like web graphics library, that's basically JavaScript API. So we need this WebGL to be able to render 2D and 3D graphics within our web browsers. Basically everything we're going to show today is based on WebGL. So we're just having stacks upon stacks, but in the core of everything is WebGL. It allows us the GPU accelerated usage. So basically we have like physics, images, textures, whatever, so we can use them to project them onto the web canvas. Some short history facts, which I think are relevant because we're in Serbia. So WebGL evolved out of the Canvas 3D project by Vladimir Vukicevic from Mozilla. So basically Serbian is responsible for this. Later on, Kronos Group started working on it, and in 2011 we have the first version of WebGL, like first specification, and after that things started to speed up. There were a lot of developers, like community became bigger, and we saw different solutions, different test projects. In 2017 we have WebGL 2, which is basically based on OpenGL ES3. Right now it's supported in all major browsers, so both mobile and desktop. We're gonna use today 3JS library. Basically this is a JavaScript library that allows us the creation of 3D animations, let's call them animations, using JavaScript, but without relying on any other plugins, any other libraries. Basically 3JS is consistent, contained from WebGL. Basically, it wraps some of the features that WebGL has, and we're basically having like an easier approach to shaders and stuff like that through 3JS. So you can see here a little bit of short history about that. 2010 it was first released, and right now we have release 19.6. So there are a lot of contributors to 3JS. It's open source, of course. And when you go to their website, you can see a ton of crazy projects, like even like big movie studios, when they're doing promotions, they're also using 3JS for some animations to promote their movies and stuff like that. So it's very, very good. So I'm going to show you now one example of like basic usage of 3JS. We're just going to create a simple cube to demonstrate how easy it is to work with this, and how the later technologies that I'm going to show rely on 3JS. Here you have a link. This is my GitHub page. We're going to go with the example one now, but if you go to this web mixed reality repository, you can download everything, even this presentation if you need it, so all the links are there. So we're gonna start with Visual Studio Code. I've increased a little bit the font so you guys can see what's happening here. But basically we have a simple HTML page with reference to the 3JS library here, and we have our script code that's basically doing what we want. So it's basically creating the scene that we are going to show. So let's start from here. We're not going to go through each line, but this is the first example, so I want to show you how this works. Basically, when you imported the 3JS library, you got the 3 object, and within it you have a lot of functions. So basically, first thing is to create a scene, and once you created a scene, basically everything else you create later goes into that scene. So cameras, models, objects, geometry, materials, everything goes into that scene. We're also creating a camera object, which is basically going to be the viewport. So where the camera is looking at, that is the scene you're going to be able to see. We're setting some positions initial here. We have a WebGL renderer. Basically, the renderer is the part of the code that generates, that combines our scene and the camera. And here we're creating, we're of course adding this renderer to our page. So that's how we're going to get the canvas, and it's going to enable us to project something onto that canvas. We're creating one box. So we said we're going to have just a small box that just rotates for this first example. And we have some material that we're going to apply to that box. So that box will have some color. Nothing special here. And we just add, so we combine this geometry and material into this mesh, and we have this cube. We add the cube to the scene, and that's it. We've set the position of the camera by set axis, z-axis. So that's just initial. You can do whatever you want here. You can position it where you like. And we have this animate function. So this is basically the most important part. Animate function is called constantly in a callback. And this is the part of the code that basically allows you to animate objects. Generally, it can run up to 60 callbacks per second. So you can generally get a 60 FPS. It's kind of dependent on the browser itself, but 60 FPS is completely reachable and doable. We see here that whenever this animate is called, and as I said, it's called 60 times per second, we're changing the X and Y coordinates of the cube by 0.01, and as it's being called constantly, this animation effect is achieved. And we just call it initially, and it will be called constantly later on. So as I've said, you can run an HTTP server here in the folder where the repository is. You just need to run the HTTP server. It's just like this, but since I'm already running it, I won't do that. As I said, you can install this. This is an npm module. Everything is open source, free of charge. So as I'm already running this, you can connect to my my computer, but let's first show you what we got here. So this is the first example, and basically this is it. This is the cube. It's rotating. It has this green weird color, but this is the scene we've created with this couple lines of code. So nothing special. It doesn't look really interesting, but this is just the beginning of the story. And as you can see, everyone can create a simple animated 3D scene in the web browser. You can also, if you want, you can connect to my computer from your phones if you're connected to the Wi-Fi of the conference. So you can basically hit my server. You need to type HTTPS 172.18.1.223 8080. I'll just type this here somewhere so you can actually see this. So to be able to run this, you will have to be connected to the Balkan secure Wi-Fi. So you can try to hit this. Let me know if you managed to do this. So it's HTTPS. Don't forget that. You'll get that it's not secure. The only reason why I'm running HTTPS is because for some later examples, we have some problems with iOS. So iPhones have some weird problems there, and they require HTTPS to be able to run some of the examples that are using the camera later. But generally, if you run it locally from your machine, HTTP is quite enough. There's no problem there. I generated some simple certificates so you can access this. Okay. So as you've seen, this is the scene. You can also see it on your mobile, and that would be it. So the next thing we're gonna take a look at is how we can import a 3D model onto our 3JS scene. We saw how to create a scene, how to create a camera, how to add the camera to the scene, how to add different models. But now we're gonna import a 3D model, which is basically an OBJ file plus some material files that it has. I basically created in 3D Max 3D model of the logo of Balkan, so we're gonna use that. We're gonna use this 3D viewer, and that's it. You have the link also here, but if you just download the entire repository, you're fine. So let's go to the example 2. Maybe let's just go here and show you the example. So this is the 3D model. I've added some event handlers, so as you move the cursor, it kind of reacts to that. So you can see this. You can also run this on your phone. You just go to this and then example 2. Should be able to run it. So let's see how are we doing this. So we're still not in VR, AR, we're still in the browser 3D world. Okay. So here, as I said, basic HTML, some CSS that you can analyze yourself just to color the background and stuff like that. I'm loading the 3JS library, and I'm loading also two JavaScript files, which is object loader and material loader, which I need to import the 3D models onto our scene. The code now is in a JavaScript file. So here we have script.js, and that's it. In the script.js we have the logic. Let's first take a look. So as I said, in the Visual Studio Code, in the extensions part, you can install 3D Viewer for Visual Studio Code, which is a pretty good and free alternative just to make sure that your 3D object model is good, it's properly configured, you don't have any problems with importing it. Not sure how much are you working with 3D Max or tools like that, but the thing is, depending on what kind of tools and plugins for 3D Max you're using, you're gonna have problems importing them onto your 3JS scene if you didn't export them properly. So this is a pretty good tool to make sure that your code is fine, but the model is wrong. I spent so much time like just debugging through the code why the model isn't loaded to figure out that the model was wrong. So this tool I can recommend. So 3D Viewer for Visual Studio Code. Just go back here. The objects are like the OBJ file is in the assets folder of the example 2. So we can just go right click and open in viewer. And we have a mesh preview of this, so it kind of looks like a spider. But you can see immediately how it was exported, so where the front and the back is facing. So if you just imported it like without any repositioning, you'll get this. So this is also very good to know how you need to rotate the object itself to be able to show it properly. So you can see here, when I go up, you can see this is the logo. There are no textures. This plugin does not load material files, so you won't be able to get any textures here, unfortunately. That's for now. It has some ability to load some materials, but it's not working for the custom materials for now. But this will be fixed pretty soon, I think. So as I've said, we're on the example 2. So we ported everything from the JavaScript code to the script.js, so we don't have anything in the index HTML. We have this window on load. Basically, we have this function here, so we can make sure that the body and everything within it is ready, so we can inject DOM elements into there. So that's the only reason why we have this. We have a couple of variables here. The container, which is basically the element that we're gonna add our scene to. We have the camera scenes, renderers, positions of the X and Y from the mouse, because we have that interaction as I've shown you. And the only reason we're calculating these two, window half X, window half Y, is to center the element, to center the scene. So we call init and animate functions. So we've seen what the animate function does previously. It's a little bit different here, but still it's basically the same thing. In the init function, we're creating an element that is going to be our container, and we're going to add it to the body. We're creating a camera, and we're positioning the camera. We're creating the scene with 3JS, same as we did in the previous example, and we are adding a couple of lighting. So why are we adding lighting? Because we want to have a little bit nicer effect with our model. So we're adding two lights. We're adding ambient light and point light. So as you can see here, the ambient light just globally illuminates, but it's not able to cast shadows. but the point light gets to like replicate something similar to a light bulb. So you can have a point light directed at your elements. How it's directed? Well, you can see here that the ambient light is added to the scene. So the entire scene has an ambient light. But you can see here that the point light is added to the camera. So where the camera points, that's where the light points. And we just add the camera to the scene. This is just a progress loader that I'm using when I'm loading the model, so nothing too important here. This is the part that's different than the previous example. So as I said, we're using material and object loader since we have these OBJ and MTL files, which is our exported 3D model. We're using these loaders to load the material here. We just reference the path, it's in the assets folder, and we get the materials. We call the preload method on them, and once we load the object, we set these materials onto their object. So you cannot just play around with different materials if they aren't exported for that OBJ file. So if you exported it in the 3D Max, you need to export a material with an object. You cannot just take another material and apply it here if it isn't a simple material. If it needs to follow the structure of your model, it has to be an appropriate file. And we're loading this. We position the object, we rotate it a little bit. Why are we rotating it? Because as I've shown you in the viewer, it's being flat, so you can see the back of the logo, so I need to rotate it and change the position. Again, we're setting the renderer, and we're setting some pixel ratios, and we are adding the renderer onto our container. I've added these mouse move and resize events. You can do this without them. They're not mandatory. But basically, you can see on window resize, I'm updating the size of the canvas, and on the mouse move, I'm changing the position of the element. So in animate, we're calling request animation frame. Request animation frame is basically a function that tells you that you want to perform an animation. It is it's browser's method. It's attached to the window, so it comes with every browser. We call the render method, and we can see here if the position of the mouse changed, we're also changing the camera position. So basically, as the object lies flat, we're just moving the camera, and we get the effect that this is moving the object. We point the camera to the scene, and we're calling this renderer over and over again until we exit this. So as you can see, this is our Balkan logo in 3D. Okay, so where in this story comes VR, AR, mixed reality? Once we had 3JS, there were a couple of different attempts to try to transfer these models into virtual reality. And when developers decided that this might make sense, and after our phones started to get a little bit bigger and more advanced, and like more hardware was there than usual, we started to develop some VR experiences that were basically some simple games, simple examples, like playgrounds, and with the availability of this hardware, someone figured out, wait, well, so we can use this, we can use the gyroscopes, we can use generally the screen of the phone to display virtual reality. We're just going to have a couple of lenses, and we're going to attach the phone to the lenses, and we're going to get the effect of virtual reality from our phones, and we're going to do that like very easy, very cheap, and that's where the A-frame comes to the scene. So it's basically a web framework for building virtual reality experiences. Originally developed from Mozilla, still being actively developed. It's very easy to create your own VR content. As you can see here, it supports many different vendors. So you can see Oculus, Gear VR, Google Cardboard, Mixed Reality, Daydream, and others. Why there's a benefit of using this instead of using native apps? Well, basically we're developing everything in JavaScript. Everything is run on the browsers. The browsers are running on each of our phones, and it's basically free. So it's also based on Three.js. So this is why we had that intro of WebGL to Three.js, now to the A-frame. It has full access to the Three.js API. It's just like kind of as Three.js is a wrapper around WebGL, A-frame is a wrapper around Three.js. And this is how they advertise it, like VR made simple, declarative, cross-platform, entity component architecture, performance, tool agnostic. I wouldn't agree about the performance part, but the rest is pretty good. So now we're gonna show you an example of a basic A-frame scene. It's kind of like a plane. It has a sky, and onto that plane we projected a couple of cubes and stuff like that. We're gonna see like the basic manipulation of this scene, so we can move through it, we can look around, and I'm gonna show you the visual inspector, which is a very good tool. If you ever did coding in Unity, if you ever developed a couple of games or something like that, you know that the Unity editor has the ability to move the objects into the scene. You can reposition elements and do stuff like that. We'll see how we can do this here. It's very difficult when you're creating VR scene, basically any 3D scene, but we're gonna stay at the VR part. It's very difficult for you to know how to reposition your models onto the plane, where to position the camera. You will have to guess like the coordinates, X, Y, Z, and that doesn't make a lot of sense, so that's why we're using this inspector. And of course you can run it on your phones. As I said, for the running, you just need to go to HTTPS 172.18.1.223.8080. You need to be connected on the Wi-Fi. So you are going to be able to run this on your machines. So I'm gonna leave this, but first let's go to the third example. So here we're seeing one A-frame example. So it looks pretty basic. So who can imagine that this is a VR scene in the browser? We're just loading the library, and that is everything we need. The library itself has Three.js, so we don't have to load it separately. And what are we doing here? So we're in the body, we're adding a scene. This A scene is basically exactly the same scene that we've added in the previous examples through Three.js, but it's just a wrapper. So these elements are basically applying shadow dome, and they're just rendered in the background. Each element here is basically describing itself. So we can see a box, we can see a sphere, we can see a cylinder, we can see a plane, we can see the sky. So it's pretty clear what these elements are. What might not be so clear is how they are all connected. Well, they're connected because everything is added to the scene, and to make sure that the box and sphere and cylinder are on top of a plane, we need to reposition them properly, right? So let's see how this looks. So we go to the example 3, and we have this. So it doesn't look like VR, right? Well, not without the glasses. But we are able to move around, and this is basically what you can do with your phones. So if you go here again, you open this from your phone and go to the example 3, you'll be able to run this on your phones. When you click on this on your phones, you will have a split view, which is basically used for VR. So I have here Gear VR glasses, so after the lecture you can take a look how this works actually in VR. It doesn't make sense for me to put them on and say that it works. What I've said here is it's sometimes very hard to reposition these elements. Basically, if you look at the code, we have some coordinate positioning, so -1, 0.5, -3, stuff like that. These numbers are not something you can just get out of your head and just type them around. If you want to position them properly, you would have to change, refresh, and do that a couple of times until you get it right. So that does make a lot of sense. So we're using the Visual Inspector. Basically, here, as I said, on Windows, you go Control-Alt-I, and on the Mac, you go Control-Option-I. So we're just going to open it. And we can see how this scene looks. So if you ever did something in Unity, there's some resemblance here. So what are we seeing here? So you can see here, there's our camera, and this is, the yellow is where our camera is pointing at. The green is the plane, the color part of the plane, and we can see our elements. We can select our elements, we can change their position. So we can place this, let's say, somewhere here, turn it off, and see that it really did move. We can also see that our sky around here, just I need to position it properly. Each element here can be moved from different axes. So it looks pretty similar to the Unity. So here on the right side you can see basically the properties of these objects. So you can see their position, their rotation, their scale. You can also change everything from here. You have the ability to change the element itself. This is something invisible, but of course these are the basic elements. If you want to use different custom elements, you would have to import your own. You would have to change a little bit how this works, but this is a good demo of how to create a simple VR scene. So now we've created a VR scene that runs on our phones. So let's try to do something different. So we've used just these basic models, but we want to import our Balkan logo to the VR. So we have this 3D model that I've shown previously. So we're going to import that 3D model with the texture onto our scene, and we're just going to do a little bit of repositioning of the camera. Because the exported model is a little bit too big. So we need to scale it a little bit, and that's it. So let's see first how this looks. So we have here our Balkan logo. As you can see, I can move towards it or back away, left, right. That of course won't work on these cheaper versions of VR headsets because they only track the movement of the head. So it's basically gaze based. They don't have, of course, eye tracking or something similar. They have gaze-based view, but with some more advanced headsets that have the controllers, you're able to walk through the scene, so you're able to get close to the element. Okay, so let's see how we did this. It's still pretty simple. So this is our A-frame code. Again, we're just loading A-frame and our scene. So everything is contained within our scene. What is different here is that we have two assets. The assets is our 3D model and our materials. So we're just loading these assets and we're giving them some ID. The ID that we're going to reference in this A entity, the A entity is like a placeholder which you can use to inject all kinds of different elements. So it's basically a placeholder for your custom elements. You can create any kind of custom element, export it by some name, and then as they use in the previous example, as they use A plane or A sphere, I can call it A test element and just load it here. So we're just mapping the model with these IDs. So we have the model and the material. We add the scale. The scale is added because the exported model was too big just to show it like this, and we rotate it. Why are we rotating it? Well, as you remember here, when we opened our element, the element is on its back, so we need to rotate it. Okay. We also add a camera, and then we reposition it a little bit further so we can take a look at this model. Okay. So now we've created a VR scene with our 3D model. We're still in the VR world, and I promised you we're going to talk about mixed reality. So let's go to the AR world. So we have a library called AR.js, very creative name, which is basically an augmented reality for the web. It's based on A-frame, so you can follow the story. WebGL, 3JS, A-frame, AR.js. Very complicated. Not so much. But you need to know a little bit about each of these things to know how to work in AR.js. So it works on any phone with WebGL and WebRTC. iOS has some issues. If you want to run these AR examples on your iPhone, you will have to run an HTTPS server, and it only works on Safari so far. They have bugs reported for this, but they are not so interested in solving them. But it works perfectly on Android, on Chrome, on any other modern browser. Everything is open source. The AR.js is a GitHub project, so everyone can contribute to it. And that's it. So we're going to demonstrate how we can create some AR scene. What are we doing here is we're basically creating a box. In this example, we applied a texture as an asset to the box, and we project this this box onto a surface. So AR.js has a couple of template surfaces that you can use to project something onto them. So basically, we can also create a project where we can select where we want to project something, which I will show you through examples. But we're using something called like a hero image. So it's just a white paper written hero on it. Nothing special there. You can change whatever you want. You can write your name. This is just already supported. You don't have to change anything. So let's go to the example 5. And you can see me, but that's not the point. So what happens here? So you can see as I'm moving the paper, it projects perfectly onto this hero image. This bouncing is just lagging. It's not some cool fancy feature, but it kind of looks like it is. So keep in mind that it works a little bit better with your camera phone and when you place this onto some surface and then you can walk around it. If you're running these examples on your phone or after, I can give you this so you can show around if someone is using this. So let's see what's happening in the code. Still A-frame, right? Well, just a couple of additions here. We're just adding this ARJS for the A-frame. So this ARJS is specifically for A-frame. We add a scene. We have an embedded ARJS, so we're saying that we're projecting this scene somewhere. Where? Well, we have, or like what are we projecting? So we're projecting this box onto our hero image. So this is, as I said, this image is a placeholder. You can create other presets and you can project onto them. I will show later a couple of examples of usage of doing something like this. Still, we add an asset, which is a texture, which is basically an image of the logo of the conference. And we just add that texture as a source here. And we have the box. We add the box the box is already added to our scene, but we know that we're going to project the box onto with our marker. Add the camera, and that's it. So basically, this is the entire code that I needed to create this fun thing. Yeah. So I also have a little bit different example here. You can take a look at it on GitHub, where I just projected the logo of the conference. You can see it's a little bit bigger. I didn't get a chance to scale it properly, but that's it. You can play around with this. You can have your own models. You can do whatever you want. So everything, as I said, from this code is free. You can download it from my GitHub page. You can play around with your own models. You just change the file name, and that's it. Okay. So we've seen VR, we've seen AR, but what really is a mixed reality? So this rubber duck shows us exactly what mixed reality is. In VR, we have a scene that's not real, that's virtual scene, and we're projecting something onto that virtual scene. In AR, we use our camera, or if we have some advanced hardware, we're using glasses. And we're projecting something into our space. But with real mixed reality, we're able to detect where each element is. Like, we were able to map the room, we're able to reposition an element, we're able to place a virtual chair there, and we're gonna move, we're gonna walk around, but when we turn, this chair is going to be here, where we put it originally. If that chair is behind the desk, it will stay behind the desk. You can see different applications of this. Like IKEA recently released Android app where you can basically take their furniture, you can select the furniture, and you can just place it somewhere in your room, and you can see how this looks in your room. They still didn't cover every single item that they have in their product list. Someone has to model this, but they're working on it. But the flaw with this is that you have to, because they developed this only recently for iOS, but they only had an Android version, so you back then have to have an Android. You would have to download their app. You would have to give them permissions, different kinds of permissions. I don't want an IKEA app on my phone. I really don't need it. I'm just gonna take a look at it from when I really want to buy something. I don't need it to be stored there. So I just go to their website, and if they implemented something like this, that would be quite enough. No need for an app. So, what is WebXR? WebXR is basically an API to access virtual and augmented reality devices. So the properties of these devices, sensors, head-mounted displays, but for the web. We had something called WebVR, which is still active on a couple of older versions of the browsers. They're currently in the interchange going from VR to XR. So you can, when you try to Google these things, you can see different people are calling something WebVR, people are calling something XR, they're calling ARJS, and it's a little bit confusing right now, since this is an API standard that's still in active development. So currently Google, Mozilla, Microsoft, and a lot of independent developers are working on developing this API standard. The group is called Immersive Web Group. Everyone can participate. You will just get a lot of emails because it's pretty active. I'm a member, but not an active member, since it's kind of difficult to be involved there, as they have regular meetups in USA, and I'm not there. So XR basically says that hardware applications and techniques are used for virtual, augmented realities, and other related technologies, which is kind of a mixture of these things. So this is head-mounted displays. So independently of are they opaque, transparent, or using video pass-through, as we did with our cameras. This is a video pass-through. Mobile devices with positional tracking. We have all of these things in our pockets all the time. And fixed displays with head tracking capabilities. Also, we have this in modern phones. When you put Samsung into this Gear VR, you're going to be able to see the head tracking. You're going to be able to see gaze-based views, basically. So Mozilla shipped WebVR API in Firefox in 2017, and that's how they started working on this. Very soon, Oculus browser, Samsung Internet. Samsung Internet is the browser that's enabled when you use Gear VR and when you attach your Samsung phone. They supported this. Microsoft is shipping WebVR in Edge. And then VR frameworks like A-Frame and React VR gain massive popularity. So we've seen that A-Frame works on my laptop, but how does it work on the phone when I put it in a headset? Well, because of WebVR API, it's able to use the WebVR API and to get these positional tracking elements, so you can actually do the gaze-based view. Also, there are a lot of VR tools for this, like Visor, WebVR Studio. Some of them are even now getting deprecated because they keep developing new features. So in 2018, as I've said, they decided to change this and to provide access for both augmented and virtual reality devices. So they only supported VR, but now they're supporting also AR. And we have a couple of different experiments. Right now it's supported in Chrome. You need to uncheck a couple of these extension experiments to be able to take a look at this. But there's also a couple of different viewers. You have WebXR viewer for iOS, so you can actually use this on an Apple phone also. But it works in your Google Chrome. So these are a couple of examples that I wanted to show you of WebXR. This is some kind of a draw app. Basically, you're able to draw something in real space. It stays there no matter how you move it. You can go around it. It will stay there. So this is an A painter from Mozilla, from their examples. We can see a moving and rotating model using Google's 3D model viewer. You can actually see how this works. Okay. They just filmed the phone, but basically. So the idea of this is, of course, to enable users with already existing hardware to have immersive experiences only with their phone and with their headsets, whatever. They don't have to buy anything new. Later on, when we get to the stage that we have glasses, we will already have a prepared like infrastructure and code base for these experiments. So we can see an example of the application. So you just give someone your business card and he can do things like this. You can see there are a lot of different and possible applications of these solutions. The only limitation here is your imagination, I think, and a little bit on the hardware and software side, but for these things, not so much. And that would conclude our session. As I've said, like I have here Gear VR. I also have this Leap motion controller that I'm gonna show you later to play around a little bit with it. But you can run everything from your local server machine. You can connect it with the projects that are on my GitHub from your phones. And if you have any problems, you can also contact me. I'm available on Twitter, on my website, or also here after we conclude this session. So that would kind of be it. Thank you. So that's it. If you have any questions, you can raise your hand. You have, okay, so the mic.
So regarding the processing, everything is done locally on the device that is currently using the app, the web page. Mm-hmm. So is it possible to put up a server to display like at least a part of the graphical calculations?
Yeah. I mean, every single one of these examples are hosted locally on my machine, but we can push them to every individual servers, whatever we want to do. Like we can also create company web presentations in VR. We just give them like a QR code. They just scan it, and it goes to the web page, and we open an immersive AR scene there, and we can maybe show them new products that we have and stuff like that. We can do different things. I mean, also like these business cards. You scan a QR code on your business card, and it opens entire profile on your phone just by visiting the targeted web page. So you can do whatever you want.
Yeah, I just wanted to know if there's a significant loss. For instance, if you can notice the app working slower or whatever.
Between the difference from my machine and running it?
Yeah, on the server.
No.
Okay.
It basically just depends on your latency, and that's it. You can ask whatever you want if you have some questions more, or later we can talk.
You experiment with,
Just wait for the mic.
did you experiment with moving human models? Last week I met some guy which made XR application with like a discotheque where the people are dancing at home and all is happening on the one scene.
Yeah, you can. We've seen here how to add static objects onto our scene. Animating them, it's also very possible. You basically, how would you do this? Like, how would I do this? I would first create a scene in 3JS, as we've seen, and animate that scene there. And I would just reuse the scene that would I pack into an element and just inject that element there. So you can do basically any kinds of animations. As you've seen in the last example, this is an animation, but you've seen a 3D model being animated. Not exactly the same thing, but still very doable.
Thanks.
Can you use some kind of events like clicks or something to send to backend, and on backend you can save?
Yeah.
Yeah, you
can basically detect a click or like a pointer. As I've said, you have this gaze-based view, and you always have the center of the camera. And if you ever used any of the VR experiences, you have that click thing, and it basically detects the intersection from the camera point to the element itself. So you can detect the click, and you can catch that click, and you can do whatever you want. You can send requests, you can require some animation, whatever. Yeah, it's very possible. Nothing complex there. Okay, so that would be it. Thank you very much.